Hi, I'm Chetan. I'm the team lead for the team AIT Syndicate. So we have applied in the problem statement 25237, which is multi-platform system hardening tool. So let me give you a little bit of background. You know the problem statement already. We have built a solution for this. I'll be showing you that in this video as well. Apart from that, we'll be showing you the kind of approach we have used and what we are planning to do further. So let me give you a little bit of background. So today, in today's age, firstly, the system misconfigurations remain one of the biggest cause of cyber breaches. Even with CIS benchmarks and SDLG available, manual hardening is very slow, very inconsistent, and very much error prone, especially across mixed systems like Windows, Linux, CentOS. It is a big hassle for these IT administrators, security admins to patch up all of these systems. And secondly, it's very inconsistent because there may be multiple people who are doing that, and it's not very standardized. So our goal here with this problem statement is to make compliance both automatic, verifiable, using the existing systems and a blockchain-backed audit layer, which can be verified if what all problems were there, what all patches we did, all of it. So let's get into the approach first, and then I'll show you the complete solution which we have built. Yes, so this is our PPT. Our team ID is 66622. Yes. So let's get into this. Let's start with the idea and solution. So we have built a cross-platform Python-based tool. We have chosen Python because it can be compiled in different operating system with the same tool chain. So that is why we have chosen Python. Uh, so this solution will run on any kind of operating system which supports Python. So what our solution does is it firstly finds out all of the misconfiguration like root SSH may be on, guest accounts may be there. So it finds out all of these configurations. It applies secure parameters and generates compliance reports based upon all of these patches and everything, which are verifiable upon a private blockchain, which will be implementing. Uh, it's this whole solution supports rollback as well. That is, if you do not want some kind of patches, then you can just safely reverse it. Each enforcement cycle is digitally signed, and all of this is put on a blockchain. The reports which are created in the end are hashed with SHA-256 and are put on a private blockchain ledger. This works with any kind of operating system like Windows or Linux, any kind of distro basically. We have implemented it for Windows, Ubuntu, Linux, and CentOS for now. We have provided both CLI and GUI in this solution. The USP of this solution is obviously that it's firstly cross-platform, that is same tool for both Windows and Linux. The rollback is very safe. That is, you can just reverse all of the patches with just one click of button. The annexure, which basically the file which provides all of the patches or all of the checks it needs to do, is in a JSON format. That is, you can just expand it by adding more checks into the JSON file, and it will start working out of the box. Then firstly it is built on Kinter library for Python, which is very lightweight, and all of the solution is offline. We identified some problems and we have resolved that as well. Firstly, that it is very manual and error prone, this OS hardening process. Then, so we have implemented this automated enforcement. Then there is inconsistent baselines, that is, multiple people may add different baselines, or uh, there may be different baselines for different OS. So we have created unified JSON wherein you can just add Windows and Linux uh, patches and verifications, and it will just work. Secondly, we have added a HTML plus PDF signed based report generation. We have safe rollbacks, a central dashboard for summarizing all of the compliance report, and blockchain based hashing for verification auditing. Uh, all of this is fine, but let's get directly into the technical approach which we have followed. So as soon as you start the tool, you can either go for GUI or CLI. GUI looks like this, which I'll be showing you later on. This is the CLI. So in CLI, there are multiple options which are available in GUI as well. You can use CLI or GUI. For CLI, we have built an executable which does all of the tasks. This both have the same fundamental structure. So first, they detect the OS, if it's Windows, Linux, CentOS, through Python's inbuilt module called Crystal Platform. Then we parse the whole policy which we have created in the annexure. If you want to add, you can just add more policy into the annexure, and it will work. So that goes into the enforcement engine, which is a Python script. which runs different bash scripts for Linux, which runs PS1 scripts, that is PowerShell scripts for Windows. So they go into the enforcement engine, which enforces all of the rules based upon adapters. Uh, it logs everything, basically all of the patches, all of the checks. It logs everything and creates a compliance report out of it. All of this is stored in SQLite database, which is a very lightweight database. This all of these changes, all of this policy and everything go into a blockchain ledger. The adapters which I mentioned earlier are basically files, basically the scripts which we have created, which do the whole modifying the system configuration and everything, both for Windows and Linux. For Linux, there are bash files. For Windows, there are PowerShell files. Uh, for different target systems, there are different kind of configuration that we are supposed to do. So we have implemented that as well. In network stack, there may be IPv forwarding start that may be on HMP redirects for authentication, firewalls, so all of these, which I'll be showing you later on. All of this goes on to create a compliance report, which has the before and after states. It has timestamps, severity mapping. All of this is signed using PKI and ECDSA keys and put on the blockchain for verification and auditing. So let's get right into the POC and prototype. I'll show you what we have built, the solution and all for both Windows and Linux as well. Yes, so let's start with the Windows part firstly. This is the command line file, the CLI file, which will be created into an executable. And this is the GUI code. It does all of the patching and everything from this annexure. This annexure has all of these different properties which it's supposed to implement. For example, this ID Linux is SysCTL01. It checks if IPv4 packet forwarding is on or not, and it disables that. Then this disables ICMP redirects and acceptance. So these are for Linux. This annexure has a lot of properties which will be implemented. So for example, this Windows registry one, this disables all of the guest accounts that may be there. So let's see this in action. So I'll start the GUI. So as soon as I start this GUI, this has nothing right now. This is the MVP. You can firstly start with a dry run to check if it's running or not. So let's start with complete enforcing of all of these processes. So this starts enforcing all of these here. So once everything is done, it will give us checks here. It takes a little bit of time, so let's wait for that. Yes. So it checked all of these. Okay. So it checked if, for example, a disabling it does the pre-check. It failed because it did not have the privilege to do this one. We will add the privileging and everything. Privilege is there for the system admin, so this won't fail there. You can see there are successes. They are skipped. Skipped means that it was already compliant, and hence we do not need to do anything. Pre-check is basically the checking and everything. You get all of the logs here like this, and all of this goes into a report as well. So this report is the one which we'll have it. Uh, just a second. Yes, so the report is created here. So when we open this, it shows us something like this. So the run ID was this. We started this. It shows that the OS was Windows. It is tried to disable. The severity was low because guest accounts are not that important. So it checks all of the. Right now, we have only added low priority policies, so it goes low everywhere. So, for example, it has different kinds of checks. So, for example, ensuring Windows firewall is publicly enabled, it pre-checked it and it was already enabled and hence it skipped all this patch. So we have patch in and everything. Compliance, we get the compliance percentage of 32%. So it gives us a compliance percentage as well. Uh, so this same code which with some minor changes. For example, here it only ran Windows Get Registry and Windows Set Registry. Uh, for Linux, it will be running this Linux set system CTL set command and everything. I'll show you the Linux part as well now. I am using a virtual machine for this. So this is a Ubuntu-based virtual machine. Letting me power up. Yes. Yeah. So here is the code base. So using Terminal. So we had this is the same code with minor changes. For example, if we just delete these reports so that it's easier for us to see if it worked or not. So this is the GUI here in Linux. So let's start enforcing it. So this does all of those checks and everything. And once the checks are done, it will create this report. It says that it has created the report that reports CF299C3, which is here. So we can just check that. So if for pre-check it was skipped, for pre-check it was skipped, basically means that this was already compliant and hence it did not need to do this. Uh, it was successful in this. Most of them passed with it was it successfully detected the Linux. It was able to find out different IDs which were specified in the policy file. That is the annexure. So this is able to solve most of uh, the policy problems. Yes, so that was the POC. So I'll tell you the feasibility. Firstly, the technology which we have used is openly available. It's open source, and hence there is no dependency for proprietary. It's cross-platform ready. That is, it's tested on Ubuntu, it's tested on Windows, and it's very lightweight. It's expandable and modular. That is, you can just add new policies to the annexure and it will start working. The performance is very fast. This being the complete compliance and everything can be integrated with SIEM and SOC tools. Uh, the technology stack is Python 3. We have used SQLite for the temporary database. We've used Jinja to PDFKit, Bash, PowerShell, and for Hyperledger Fabric for the blockchain part. The use case is obviously for defense, IT tells, SOC teams, the scalability is this complete dashboard can aggregate all of the results, and it can align with all kind of benchmarks. There were some challenges, obviously. Firstly, that the permission issues during enforcement. We can run this via sudo or admin rights, and hence it will run all of the policies which is supposed to run. There are different OS variations. Then for that, the annexure is modular. Misconfigurations could be there. So for that, we have pre-validation and rollback. There is obviously impact for defense and government. There is impact for corporate, education, and research lab may also benefit from this. Main benefits there are operational. Firstly, that uh, the manual hardening process and finding out all of the problems and hardening it and everything. Time is basically cut from hours to minutes. Uh, it's this tool can work on all kind of OS, so they do not need to think very much. It can this project enables periodic compliance. That is, you can just add in a cron job and the executable or binary can just do it periodically and create different reports which could be put on the blockchain. Uh, then there are economic benefit that is there is no licensing cost. This is full open source. All in all, this project has a lot of impact and hence we are building it. We have built most of it, but there is a lot of part. For example, the blockchain report part is left. Secondly, we'll be adding in more policies and making it more robust and more comprehensive. So that is the part which we plan to do in the hackathon. So this was our solution. For the problem statement 25237 multi-platform system hardening tool, our team ID is 66622. Our team name is AIT Syndicate. Thank you.